So I just wanted to give you the heads up that you will be getting a couple things like this in the near future, to where I will send it home and ask you, this is kind of to lead you into starting to look at your book a little bit more. I know that the book is a little overwhelming. You can't highlight in it, you can't write things in it. So you'll get little things like this where I want you to show me that you're highlighting and you're writing a couple words on the side, any annotations, and I'll start taking those for grades, okay? So just know that this is going to be included as a homework grade. All right. So today, hopefully you reminded yourself about solutions being homogeneous mixtures that involve a solute and a solvent. Okay, the solvent or solute, the thing that is dissolved. Solvent does the dissolving. Remembering that water is a polar molecule, that's why it's usually a universal solvent. Hydration is just another word for dissolving, because it pulls apart a solute. Okay. How polar is water? Polar. I don't know how to answer that question. It's very polar.
So what makes it think of polar?
Okay. And then solubility is just how much solute can be dissolved in the solvent. Okay. So properties of aqueous solution. So aqueous solution just means that it's mixed in water. When you hear the word aqueous, okay. All right. So electrolytes are what we're going to focus on. Remember that you got strong, weak, and non. Your strong ones tend to be your soluble ions and strong acids and bases. I have that written off kind of to the side, okay? These are the ones that completely dissociate. So that's what you're looking for, the things that completely dissociate, okay? And then your weak ones are the ones that aren't going to dissociate. So a lot of your weak acids and bases fall into this category because they will conduct a little bit, but because they're not completely dissociating, they don't have those free ions just moving around, okay? They kind of still stick together. And then you finally, your non-electrolytes tend to be things that are non-polar, and they just don't have ions that are going to split apart. You don't have any charges, okay? This little drawing down here, you have another version of that drawing, but you want to make yourself familiar. What do you guys notice I have pointing towards my sodium? The oxygens, good. The oxygens, all right? All those little Mickey Mouse things, those are water molecules. So my oxygens are pointing towards the sodium. Why? What is oxygen? Negative. And what's sodium? Positive, right? And then for the chlorines, who's pointing towards that? All the hydrogens, okay? This is hydration right here. This is dissolving. Those little water molecules get in there and start ripping them apart, and they're going to be facing towards the side that they're going to be attracted to, okay? You should be ready to draw this. We're gonna go to the next packet, okay? So what I recommend is over the weekend you do continue highlighting in the other one that you started with, okay? Huh? You had two that you picked up from them, but that's not the first page.
Water could be a solid.
Okay, so on your page, I gave you a little square. You're more than welcome to practice that on your own time. Don't worry about it. Hydration, we just went over that. So again, on your own time, please fill in that definition. I think that's a good practice for you. It's another word for dissolving. And then solubility, you have that definition as well. Okay, so for strong electrolytes, okay, let's write down just a few things to remind us of the common things. So one of them is going to be your strong acids, right? Actually, let's just put completely dissociates. Okay, so definitely your strong acids and your strong bases, which we'll remind ourselves which ones those are, and then soluble ions. So you got to look at your solubility rules for that. Yes?
Your nervous system.
Yep. All right, so a couple of strong acids. What is the big thing that we remember? I
bring clay.
Yes. I bring clay. Okay, I'm not gonna write the sentence, sorry. I don't have enough room on mine. All right, so I bring clay. That means that HI, HBr, HCl. Okay, I'm so sorry, those are all smushed together. You guys got the idea? Okay, cool. So those are your strong acids, as well as 2 or more oxygens than hydrogens.
Is HF not a strong acid?
Mm-mm. No, HF, because fluorine is so electronegative, it's going to be holding on really, really tight. It does not dissociate very nicely. It dissociates just tiny bit. It'll be considered weak.
Yeah.
All right, your strong bases, how do we find those on your periodic table? We make a what? A B?
Oh, yeah. That was an L. Oh, no, not right.
Good. So it starts at lithium, goes all the way down to cesium,
Then it goes up to magnesium.
barium, and up to calcium, actually. Stops at calcium, okay? So these guys are the strong bases. Any of these attached to an OH are your strong bases. Those guys are going to be the ones that let go, okay? They completely dissociate when put in water. Thank you. Okay. All right, so your weak electrolytes, the thing that I would remember for that is going to be that it's your weak acids and your weak bases. So basically, if you're not strong, you're weak. It's horrible. That's a motivational poster.
That's a weird video like this.
Oh.
My lord.
Okay. All right. Non-electrolytes, common ones that you can think of right now. Sugar.
Spice.
Sugar and spice and everything nice, yeah. And then insoluble things. Okay. All right. We're going to come back to that question in a minute. So let's look at our list and let's decide a couple of these things, okay? I also want you guys to practice a little bit of naming because I think it's good for you. I'm going to zoom in so that I can write. Okay. All right. So to start us off, we have HClO4. Who the heck is that? Is it an acid or is it something else? It is an acid. Who is ClO4? Perchlorate. So since it's 8, we're going to say ICI 8. So this is going to be perchloric acid. All right. Is this a strong acid or a weak acid? Strong, because we have 2 or more oxygens than hydrogens. So this is going to be a strong acid. So therefore it is a strong electrolyte. Okay, that's what it's asking.
Do more oxygens make it a stronger acid? Or is it just more?
Yes, because it's going to be pulling a little bit more. If you kind of think about the structure, the oxygens are pulling in a whole different way, so it'll dissociate a little bit more better.
If it were to have like more hydrogen, would that mean it'd be like really weak?
Yeah, because it's going to be a little bit more balanced. So think about the polarity difference here. So when you have more oxygens, you got more of a pull. When you have equal hydrogens and oxygens, you're kind of keeping it together.
Fatty acid.
Huh?
Why is a fatty acid called a fatty acid?
I'm not sure. Sorry. All right. Okay, so it also says to write the dissociation equation. So when we're doing that, you're literally just splitting this thing apart. All right, so we have HClO4. We're going to split into H plus ClO4 minus. Make sense? You see your two, those are going to be the ions. That's what's going to make it conduct electricity.
That's like decomposition.
Okay. Kind of like, yeah, dissociation. All right, so the next one, we have C6H12. C6H12. So, what are you guys thinking on this one? Just by the looks of it. I heard someone say non and a weak. What? It's a non. Anybody in bio and seen this?
Yeah. And a lot of variation.
So this is one that actually has your C's and a little loopity-loop. They kind of go like this, and then it has 2 hydrogens to each C. Okay? So this is cyclohexane. You don't have to memorize that. Just kind of recognize that when you got a lot of C's and H's, you're dealing with stuff like that. Okay?
Is there
Yes.
any naming scheme to hydrocarbons?
Yes. And I think at the end of this, I gave you a little bit of organic stuff, and you can take a look at that. Yep. All right. So cyclohexane, we are definitely going to say non. Okay, and you can tell by this little structure, that's not going to be dissociating. That's pretty nonpolar.
Do we have to draw that too?
Only if you want to. If you'd like to know what it looks like, it's just a little ring of C's with H's. Okay, I just wanted to show you why it's a non-electrolyte. All right, so now we got lithium hydroxide. What's that?
Strong base.
That's going to be a strong base. I totally gave you the name too. I cheated. Sorry. You're welcome.
Wait, lithium.
Lithium hydroxide. So this is a strong base, therefore we have a strong electrolyte. Okay? So we need to write our dissociation. We have LiOH yields what?
Lithium and
Li with a plus and OH with a minus. Yes? All right. NH3, who's that? Ammonia. Ammonia. All right. Moment of truth. Who is that? It's a weak what?
It's one of those. acceptable-
It's a weak base.
what is acceptable one?
It's a weak base. So therefore, what is it going to be?
Why have you
A weak or non? It's weak. It's a weak electrolyte. All right. So that means it's going to kind of make a basic solution in the end. So it's not just going to split. Okay. Yeah, if it's done boiling, that's fine. Yeah. Thanks.
I could use ammonia to clean like as a cleaning thing. Yeah.
Ammonium hydroxide. Okay. All right. Sodium chloride. Oh my gosh, Miss Vogel gave you another one.
Yeah. Thank you.
I just read the language. It happens. I'm so sorry. All right. So we have NaCl, sodium chloride. What do you think? Strong, because this is a soluble ion. Yes?
Yeah.
Okay, so we got strong. So therefore, we're going to have NaCl is going to make what? Na plus Cl minus. Thank you. All right.
Wait, C2H2O2.
HAC the strongest acid.
I'm sorry?
HAC.
H what?
AC.
Yeah.
All right. Okay, so what do we got here? Who is that? It's acetate. So what is this? How do you say it? Acetic acid. There we go. Okay.
Oh.
Wait, so it's a weak base but a strong soluble ion.
No, it's a soluble
That's a
ion.
different ion. So this is going to be strong. Oops. Mercedes. Oh.
Dang, this Vogel.
All right. There we go. Yes. All right. Are we good here, you guys? We're good? All right. So the other thing I want to point to on this page is down below. So we have our little silly thing. So the light dissolves light. Polar things are going to dissolve polar things. Nonpolar will dissolve nonpolar, which is fine for you to remember. But when you go to address it, when you go to justify why this is happening, you do need to address what kind of forces. Who remembers? We know it's positive and negative. What is the positive and negative attraction thing called?
Opposites attract.
No.
What kind of force is it? What kind of force is it, you guys? It's based off of Coulomb's law, so it's what kind of force? Electrostatic. There you go. All right. Put that down so you guys don't forget it. Address electrostatic forces, aka Coulombic. Okay. And you guys have all seen Coulomb's law, or you should have. Okay. I know my kiddos from last year, we did a whole page on Coulomb's law. You're going to be using it constantly. Okay. Always your justification. All right, so you need to address the electrostatic forces. That just means that positive is attracted to negative, okay? So make sure you say that. If you're curious about the nonpolar, real quick, nonpolars don't have a positive and negative end. So what's going on with them? Who remembers that? It is, yeah. All right, so we have London dispersion forces, and what are those based off of?
Momentum. Wait, no. What?
Huh? No. Do you guys remember polarizability? You guys remember that word? It's the big cloud that slams into something, and then you get a negative end and a positive end for a moment. Do you guys remember those? We forgot everything, huh? So just know that it depends on momentary dipoles.
Smashing clouds. I remember something.
Smashing clouds, yes. Smashing clouds.
I remember
Bob's sheep. Bob's sheep was the pogo that you guys did last year. All right, cool. Huh? You guys will do them this year too. All right, let's turn the page. So this one is the one we're going to look at right now. Okay? All right, let's look at some of these calculations. All right. So, formula for molarity, what is it? No. What is it? Moles over liters. Thank you. Okay? I do want you to also get used to, you can make it, just for some of your mental math, we were told this on this last training, you can also put your moles into millimoles if you're dealing with milliliters, because it's just about the ratio. Yep. So I want you to put that on there. All that means is that you're doing what to it? Dividing it by 1,000, right? And that way, for some of your mental math, you don't have to move that decimal 3 to the left, okay? Now, you guys have calculators today, so just move it 3 to the left. But I just wanted to point that out because it was actually really helpful in some of the calculations they were making us do. And I was like, oh, cool. So anytime we can fit in mental math, we're gonna. All right. So what would you have to do before calculating molarity if I give you grams? Convert to moles. How do we do that quickly? What do you divide by what? Good. Awesome. All right, we're ready to approach these. Let's look at this. First one, calculate the molarity of a solution that contains 0.875 moles of sodium chloride in 1 liter in 500 milliliters and then 100 milliliters in 6 liters. Whew. All right, so lots of stuff. So, do we have to make any special conversions on this? No. All right, so what is the first answer automatically? Yeah, 0.875, right? And if I were you, I would get in the habit of writing all the different kinds of ways that you can write the units, okay? So the next one, we're gonna write it a different way. So we have 0.875 divided by, why did I put 0.500? What did I just do?
You converted it to.
I converted it to liters, right? So you're dividing it by 1,000, so you move it 3 to the left. Okay? All right, so I did that. Did anybody type it in already? Thank you. 1.75.
I got one.
All right. So for this one, I want want you to put brackets around that answer. Oh, sorry, we should be saying what we have. All right.
Guess you forgot the L or the M.
Brackets are going to also mean the molarity. All right, that means concentration. So we're going to practice all the different units here. All right, so the next one we have 0.875 divided by what?
0.100.
Yeah, 0.100.
Oh, and we just do.
Can you guys do that one in your head?
Yes.
Why is it rounding?
Huh?
Like I got it keeps rounding, so I don't know if you're
Come bring it to me. It has fix on it. Let me see.
like I got
It
1.8
should-
for the last one was like 2.
What do you do when you have it like this?
Basically multiply by 100.
You're basically doing 875 divided by 100, which is what?
Just move it over one.
8.75. You guys got that?
Yeah.
Do we understand? Okay. All right. Since they're in the same spot, you can just divide them. All right. Okay. And then finally, we'll do this one, moles over liters. A lot of the time, I really want you to be using that. Okay? Moles over liters, because it's going to help you transition into other problems. All right? So whenever you can, that's what I would do. And then finally, last one. Do we really have to do this? Or you guys got the idea?
Let's do it.
Let's just do it. Okay, really quick. Get it? And then we gotta move on. I got 0 points. We'll go to 3 sig figs.
146.
146. Good. And I'll put a big M again. Okay. All right. Let's look at the next one. Next one's important. This was the free response actually this past year. Not this question, but it had to do with how would you prepare this solution, and you had to know the equipment. Okay, the equipment super important. So go down here for preparing solutions. Okay, because you can do the math all day, but if you don't know how to go to my lab station and actually prepare it, then we got an issue. All right. So when you are going to be preparing solutions from a solid, the first thing you got to do is you need to figure out your grams, right? So we're going to take our moles and figure out grams. That's math. Okay? So we're going to convert grams. You're going to measure it out. Measure out the solid. And place into, this is the important word right here. Does anybody know what you would put it into? What's the most precise thing? You got graduated cylinder, you got beakers, you got flasks. Remember, you have to be able to swirl it and stir it. So which of those do you guys think?
You want to swirl it?
Beakers.
Graduated cylinder?
It'd be a flask. A flask is more precise than your beakers, okay? But for this one, I want you to put this. Let's start over. What did you say? No, I'm just kidding. All right. Okay. All right. So we're going to say X up here. We're going to solve for that, right? What do we have to do with these guys? Multiply them. All right. So multiply them into your calculator, please. And don't forget proper sig figs there. How many sig figs should our answer have?
0.025.
Okay.
Should have
Should have 3. So we're going to have 0.0250.
Oh.
Yeah.
All right, so we have that many moles. What am I doing? What do I need to find from here? I need to convert it to what? Yep. So we're not dividing this time. We're going to multiply by its molar mass. So just to save you guys time, just kidding. I can't save you guys time. You got to do it. I have the process written down, but I didn't write the whole thing. Did you guys get 187.546?
Definitely.
Like 5.7.
Yeah, I got 0.57.
5.6, I got 5.6.
Come on, brother.
I'm going with what my calculator says. Sorry.
Yeah.
All right. So that means we have to have how many grams? 4.69.
Yeah, 6.9.
I think it's gonna be 6.9. All right, we're not gonna repeat the process. Just put a little arrow down to what we just wrote off on the side, because that is what you would do. You would use that many grams and then you would follow your process. Okay? Okay. Let me see if we need to do the next one. Oh yeah. All right, so the next one, read the problem. What are we dealing with now that's different? It says calculate the volume of a certain solution needed to prepare 250 milliliters of a different certain solution. So now what did we just change into?
It's, I know the formula, but I don't know the name.
A dilution.
Dilution.
All right, and what's the formula for dilution?
Oh, yeah. Dang, I set that one over for the molarity.
All right. For the steps for that one, let's go down here from solutions. This is M1V1, M2, V2.
Okay. Why'd you put minus?
I didn't. It was supposed to be a dash here. There's an arrow. Okay. All right. M1V1, M2, V2. So you would measure the calculated amount of, what do we call that main solution? Stock solution. There's your word. Okay. Place in, we're going to once again say volumetric flask is always the best. And what's the last step? Well, you can swirl, but we can also, we just need to fill it, right?
Yeah.
So let's just fill to
Fill the line.
the fill line with water.
I like that.
And the stock
Um,
solution, which one again?
And so stock solution is the more concentrated one. One other step that typically you would see is put a stopper in it and you would actually swirl it. Not swirl it, but you're gonna like tilt this thing back and forth. Okay? I'm not gonna write it, but you would put a stopper into it and you could, you just like shake it basically, but lightly shake it. All right. Ooh, that's awkward. Move him off to the side. There we go. All right. So our problem is we got 500 mils. I'm sorry, 0. What's the
That's mass one.
0.5 molarity? What are we looking for? The first volume, right? We're looking for V1. We have our second molarity. And our second volume. Should we just put it into liters or can we leave it in milliliters?
You should put it in liters.
Okay, so just a heads up, if you're ever solving for volume, you can actually leave it milliliters. When you're solving for molarity, you have to have it in liters. That's your little hint, okay? But let's just put it in liters like you guys said. That's fine with me. All right, so we got that. Do this mentally. Do that one mentally. 0.25 times 0.04. I believe in you. What do we know 4 times 25 equals? 100. So you started in the 100th space. Mm-hmm. There you go. All right. So So it's going to be equal to 0.0100. Okay. And we have that 0.5 times V. So we're going to bring that guy underneath. So we have 0.01 divided by half. What do you do there? Without typing it in to your calculator.
Is it?
So if you're dividing by half, that means you're multiplying by 2. So what is that? 0.0200. How many milliliters is that?
That's
20. Good. There's your answer, okay? So again, keep practicing the mental math, okay? Mental math. You don't get the calculator on your multiple choice section at all. Right. So starting this next exam, I'll still give it to you, but starting the third exam, you don't get it anymore. Okay? So we'll practice. We'll be practicing, I promise. All right, what time is it? All right, so number 5 says determine the molarity of the total ions in solution prepared by dissolving 9.82 grams of copper 2 chloride in enough water to make 600 milliliters of solution. What is the molarity of the chloride ions? All right, so I want you guys to get the molarity real quick. I believe in you. Just so you know, the molar mass is 134.45. Yep. Using that, get your molarity. Once you got it, let me know what your molarity is. Because I just want to make a quick point before I let y'all go. Did you get 0.122?
I got 123.
123? Okay, that's fine. All right, so cool. So if you didn't get it yet, at least write that number down and we can talk later, okay? So you have 0.122 molarity. This thing is going to be the molarity of copper 2 chloride and the copper. The chlorine ions, since there are 2, means that you need to double it. The concentration is doubled for the chlorine. So what you would have is 0.244 or 243 of chlorine. Okay, so I just wanted to leave you with that little point as molarity of chlorine, by the way, not I don't know what MCL is. Okay, so this weekend, I will post the online homework for you to start working on, and you need to highlight the rest of the reading. The reading. You do not need to do any more practice in the booklet. We're going to do that together, but you need to read. It is not all reading. It literally stops in like 3 pages. The rest of it is practice problems. Okay? Please highlight the reading and write little notes on the side for yourself.